Good morning, everyone. You are welcome to the first session of this 2023 July workshop for Mdcn licensing exams. And we are going to cover most of our multiple choice questions via the online platform. And it is interesting to note that the most important aspect of these exams is passing the multiple choice section and the picture test. Without passing this section, a candidate is unlikely to pass the exams. So one of the best means you use in passing your multiple choice questions is by answering a lot of MCQ questions. Candidates who have seen more questions, attempted more questions, and those who have practiced have better chance of passing the exams than those candidates who only read without attempting multiple choice questions. The beauty of multiple choice questions has to do with your number of attempts in practicing that. It goes beyond reading. You need a practice sessions where you kind of subject yourself to tests as well as timing. You time yourself during session. So we pray, may Allah make this session beneficial to all of us, and may He grant all of us success in our exams. So today we are going to commence with public health session, where we'll be discussing biostatistics as well as general practical community medicine questions. These are sessions that feature in all your exams. These feature in all your exams. There are some certain terminologies which you will come across in your exams, and you need to understand what they mean. And without knowing these terminologies or coming across these terminologies, if you are coming across them for the first time, you are unlikely to pass that exams. The first time where a lot of terminologies were introduced into these exams, they from public health, there was a record of massive failure because these were things that were not anticipated and prepared for by candidates. And after the exams, the postmortem revealed that these are common things that were all in the curriculum for the exams. So we are going to start the first session with multiple choice question on biostatistics. And we'll choose the single best option, which could be the only correct answer or the only odd option. Now, the first question regarding biostatistics. A says biostatistics is concerned with the application of statistical methods in problem solving in medicine and biology. B, diagnosis of a patient in a community requires a very careful observation of empirical data. C, it involves collection, organization, and interpretation of data. D, it is the same as demography. And E, it is achieved through training in statistical methods and principles. Now, if you look at this question carefully, you will see there are multiple options that are correct here, signifying that you are only going to pick the odd answer out. Now, generally, biostatistics is statistical method in problem solving in the field of medicine and biology. That is correct. Now, diagnosis of patient in a community requires a very careful observation of empirical data. That is correct. Empirical data are those data, are the data you or information you obtain from direct measurement or direct observation or direct experiment. Those are referred as empirical data, and biostatistics is all about observation, experiment, okay, or direct measurement. And the data you obtain could either be qualitative data or quantitative data. When you say quantitative data is numerical data. It's numerical. That means it can be quantified. Qualitative data is a non-numeric data. Is a non-numeric. And you know, of course, when you can quantify data, you categorize them. For example, when you say quantitative data, these are numbers. Qualitative data, you categorize, you classify data into categories. Maybe sex of the patient, you categorize that into male and females. It is not something you can quantify. You only categorize. That is qualitative data. Okay. Now, that is when we say empirical data, it's data you can observe, measure, experiment directly. Okay, that is the first question. So it involves collection, organization, and interpretation of data, which is correct. Okay, it is the same as demography. Biostatistics is a field of statistics on its own, okay? While demography is a branch of public health on its own. It's different from demography. Demography is rather the scientific study of population, okay? And the characteristics of that population. That is what demography is all about. So you can see D option is the odd option because demography is different from biostatistics. It's a scientific study of a population size, its structure, distribution, and all other characteristics of a population. That is demography. So the essence of this, we will touch some other important aspects of biostatistics. So it's important you take note on things we discuss. Now, the second question goes, which of the following will not be needed or required to determine the sample size of a study to determine the proportion of 200 level MBBS students with mobile phone addiction? Now, what is sample size determination? It involves what? Determining the appropriate number of individuals or units to include in a sample for collection and analysis. When you are doing a research, you need an appropriate number of units or individuals to recruit into that study. And to achieve that, you have to calculate the sample size for that population. Okay, so now there are some certain factors you need to consider while you are calculating the sample size of a population. What are those factors? The size of the population, okay? The entire size of the population in which you are drawing out the sample size will affect, okay, the sample size of that population. So that is an important determining factor. Now, the level, there's a term called level of precision. Level of precision, it's the level of accuracy, okay? Because what you need to understand in a research, it's impossible for you to recruit the entire population in a given geographical location. Rather, that is the essence of selecting an appropriate sample size. Now, in doing so, you need some level of accuracy. And that level of accuracy is termed level of precision, okay? And for you to get a higher level of accuracy or level of precision that will be representative of the entire population in that geographical location, you require a higher sample size. The higher the sample size, the higher the level of precision, which will represent the characteristics of that population you are studying. So we've talked about some factors that affect sample size determination. Number one, we said the population size. Number two, we said level of precision. Number three, there is what is called confidence interval. Now, when you say confidence interval, okay, is the confidence of your sample accuracy in representing the entire population. How confident you are that your selected sample is representing the entire population. And the commonly used confidence interval is 95% or 99%. When you say you are 95% confident, it means, or when you say your confidence interval is 95%, it means you are 95% sure or confident that your sample is what representative of the entire population, okay? And it means you have a margin of error, okay? When you have confidence interval of a certain percentage, that means there will be a margin of error. If you have 95% confidence interval, that means your margin of error will be 5%. So that is what it means. So this also affects sample size determination. Now, another factor that will affect your sample size is the variability, okay? Variability amongst the population, okay? That variability simply means the degree of heterogeneity, or you can say the standard deviation, how varying the population, the individuals are within that population. When you see standard deviation, is the degree of what variation of the subjects in that population. So that is what it will affect your sample size determination. Of course, the type of analysis you are doing, type of analysis will affect your sample size determination, as well as your objectives for research, and of course, the proportion of individuals that are selected. Now, if you look at your question again, it is asking about a proportion of 200 level students with mobile phone addiction. A, confidence interval. B, anticipated proportion of students with mobile phone addiction. C, precision level. D, relative risk. And E, standard normal deviation. So if you look at all the factors we listed, relative risk is not part of the factors that affect your sample size determination. Now, I'll give you an example for you to really understand what we are talking about, okay? I'll give you an example. Now, I'll just take one of the formulas for calculating sample size so that you understand what we are talking about. There's a formula that is called the Cochrane formula, okay, for a prevalence study, where you have your sample size is equal to Z square P Q over E square. Now, if you remember this formula, you have an idea on all the factors that will affect a sample size, which we mentioned. N is your minimum sample size. P is the proportion, okay, of population with that particular attribute you are studying. The proportion of population with the attribute you are studying is P. Then when you have your P, you can calculate your Q, which is equal to 1 minus P. And E is your level of precision. Okay. Now, your Z value is a value that is calculated from your confidence interval. You need to have the confidence interval before you can estimate your Z value. You can see all these factors are there, and it will affect your sample size determination. So this is a very important aspect of biostatistics. All of you need to know. So we'll proceed with the next question. Number 3 says, the following factors affect power except. Now, you should understand what a power of a study is. When you are doing any scientific research, you should understand what the power of that study is, what the power of your study is. Now, the power of a study, okay, what does it mean? It measures the ability of your research, okay, to detect true effect, okay? The power is the ability of that you research to detect true outcome, true effects, or relationship. If you are studying variable A versus variable B, and you want to know if A has effect on B or if A is related to B, the ability of that your research to pick that relationship or that effect of one variable having on another is termed as the power of your study. Now, so you should know that this power, the higher the power of your study, the better the outcome of that you study. Now, what are the factors that will affect the power of your study? There are some certain factors that will affect the power of your study, and these will include the sample size. Now, you should know this sample size is very important in study, because the larger your sample size, the more representative of the general population that study will be. So the higher the sample size, okay, it will have high power, okay? Now, if the effect is high, the effects of the variable, if a factor A has a very high effect on a factor B, that means the power of your study will be high. But if the effect is negligible, the power of your study will be low. Now, you should know that the size of a study, the size of the sample size, and the effect of the variable have a direct relationship to the power of the study. Don't forget, you should know that the sample size and the effect of that variable has a direct relationship to the power of your study. Now, other factors that will affect the power include the level of significance. The level of significance. When you say the level of significance, that is the margin of error. I told you earlier on, if you have a confidence interval of 95%, okay, your margin of error will be 5%. So you are accepting an error of 0.05, 5%. That is your margin of error. But you are 95% confident that this your sample is a representative of 95% of the population in that geographical location. Now, what do you think? If the error is high, what do you think will happen to the power of that study? If you have a very high margin of error, your power will go down. It will reduce the power of that you study. Yes, because you are accepting a higher margin of error. There are some error which you just overlook, which will reduce the power of your study. So the margin of error has an inverse relation to the power of the study, while the sample size and the effects on variables have direct relation. Okay? Another factor that has an inverse relation on the power is the variability or the standard deviation of the variable. If they are heterogeneous, the sample population are heterogeneous, there's a high degree of variability among the population of study, it will reduce the power of that study. You are lacking uniformity amongst the individuals in that study. So it will reduce the power. It is reducing the power of your outcome. You have, let me give you an example in your sample where you need to communicate with a population. And all these individuals, for example, don't understand the same language, and you are communicating with a single language. What will happen to the outcome? The message you are passing is going to be poor. So what other factor will affect the power? The choice of your test statistic. Choice of the test statistic you choose for evaluation. So let's go back to the question if you understood what power is all about. Now, the following affect power except variability or in observation. We mentioned that. Effects of interest, okay? The effect you are studying affects the power with a direct relationship. The level of significance, okay, will affect the outcome. Yes, we mentioned that, and I believe it's clear. Now, the study design, what you choose, the test statistic will also affect the power of that study, because the study design will affect the choice of the test statistics you choose. And lastly, none of the above, which is wrong, because of course you can see all the factors above will affect the power of your study. Okay. Now, number 4. What is, they said standard error of an estimate decreases as the sample size decreases. Now, what is standard error? Now, standard error is just, it just simply means variability of estimate. Okay, it's just variations. If you have multiple samples, the variations, okay, it's just sample variations. You have different samples from the same population, and there's variation among the various sample. That is the standard error. Okay, so what is the difference? What is the relationship, or how does standard error differs from standard deviation? We said when you have variation among a single data set, you have a set of data and there's variation among that single set of data. That variation is standard deviation. But when you have multiple sets of data, okay, and you have variation amongst the multiple set of data, that is standard error. When you have variation among multiple sets of data, that is standard deviation. Sorry, let's go back to our slide. I believe that is clear. Okay. So what is the relationship between standard error? Standard error of an estimate decreases as the sample size. You should know standard error has an inverse relationship with the sample size. Okay, as the standard error increases, the sample size reduces. As the sample size increases, the standard error reduces. So let us look at our options again. A, they said standard error of an estimate decreases as the sample size decreases. That is false. Okay. Standard error of an estimate decreases as the sample size increases. We said standard error decreases as sample size decreases. This is false. Standard error decreases as sample size increases. Sorry for that little distraction. Okay. We said standard error is it has an inverse relation with the sample size. So standard error of an estimate decreases as sample size decreases, which is false. So it's decreases as sample size increases, which is true. Does not change, which is false. None of the above is false. Standard error of the mean is not related to the sample size, which is, so our correct answer is D. Okay. Number 5, the standard error is inversely proportional to the sample size. This one is very clear. Okay, we've mentioned that. Sorry for the short break. So we said standard error is inversely proportional to the sample size. And so that is true. We've demonstrated that already. Okay. So the next question, number 6. Standard error is directly proportional to sample size. The smaller the sample size, the smaller the standard error. That is false. This is very clear. We said, if you remember, standard error is inversely proportional to the sample size. So that is correct. So 6 is false. Number 7, the difference between purposive sampling and random sampling. Now, sampling technique is a very important aspect of biostatistics, sampling technique. The difference between purposive sampling, which is a form of non-random sampling, and random sampling is what? Now, what you need to understand about sampling, when you are sampling for a study, the aim of sampling of a population to study is to eliminate bias. Okay? You have to eliminate bias in any study you are doing, okay? Now, you need to understand the various types of sampling technique, because if you are doing a research, it is impossible to use the entire population in that geographical area for that your study. So what you need is to take a sample, and in choosing your sample, the appropriate sample is gotten via some various techniques, and to achieve that you have to eliminate bias. So let's see the various types of sampling techniques. Okay. You have the simple random sampling. The simple random sampling, okay, is a method where you sample every unit from that population has equal chance. The bottom line, what you need to know about simple random sampling is every unit or every individual in that population has an equal chance of selection into your sample size. And the main aim of simple random sampling is for elimination of bias. So now, what other type of sampling? 1, we said simple random sampling. 2, there is what is called stratified sampling technique. What is stratified sampling technique? Now, what you need to know in stratified sampling technique, you divide population into homogeneous group or strata. Now, what it means here, you in a given population, you cannot use the entire population for study. Now you need to group this population into a uniform categories. For example, using age. Okay. Now you stratify the population into groups. Maybe age group less than 10 years, age between 10 to 20, between 20 to 30. Now you are using a specific characteristic from that population, for example, age. Now, after selecting a specific characteristic from a population, maybe age, height, or weight, then you now categorize that characteristics. After categorizing, then you now randomly select. So stratified sampling, okay, the first thing you do is you stratify uniform strata using specific characteristics of the population. So after you have categorized into various groups, you now randomly select from your uniform categories. So that is stratify random sampling. The aim also is to eliminate bias, okay? So that is another form of sampling. There is what is called cluster. Don't forget, we've talked about simple random sampling. We've talked about stratified sampling. So we'll talk about cluster sampling. Now, in cluster sampling, what is done here, the entire population where there is difficulty in getting access to individual in a given geographical location. One thing you need to understand about clustering a sample, you have difficulties in gaining access to individuals in a given geographical location. So what you need to do, you just categorize them into clusters. In that geographical location, you just make a clusters. Maybe you just say all the schools in that geographical location, the neighborhood, okay? Yes, markets. So what you just do, there's going to be difficulty in accessing all the individual. So what you just do, you divide into different clusters of population. Then you can now sample from any of those clusters you want to sample for the study. So this is another form of sampling. Then you have a systematic sampling technique. In systematic sampling technique, the first thing you do in a systematic sampling is to start with a random sampling, where each and every unit or individual in that population has an equal chance of being selected. That is the first thing you do in a systematic random sampling. So after a systematic random sampling, the next step is to choose an nth individual or nth unit. What it means, you choose a particular number, maybe tenths. After every 10th individual, you sample. Okay? But for you to achieve a good systematic sampling, your population must be orderly. They must be orderly arranged. Okay? So one, the first step of systematic sampling is to do a random sampling, where each and every individual in the population has an equal chance of being selected. After that, you now do the nth, you select the nth individual in that orderly distributed population. For example, if you say every 10th individual will be picked, so that is a systematic sampling. The reason why I'm going through all the sampling technique is for you to understand that multiple choice question, because we saw a purposive sampling there. So if you don't understand all the various types of sampling, you might find it very difficult to understand what the question is talking about. So next, you have convenient sampling. Now, convenient sampling, as the name implies, okay, is sampling individuals that are readily available. It is those individuals that are readily available that are sampled. So that is termed convenient sampling, okay? Those that are readily available and accessible. Those that are not readily available or accessible are not used in the study. So you need to understand that. Then there is the purposive sampling, the one we saw on that question. Purposive sampling technique. Now, in the purposive sampling technique, units or individuals with specific characteristics are selected. For example, you said only patient with first class will be given scholarship, for example. Okay. Now, you see, there is a purposive sampling here because all the individuals in that population have these specific characteristics. If your choice of criteria is first class student will have scholarship, anybody without first class has no business in your sample collection. So that is termed purposive sampling. The individuals or units of that population must have a specific criteria. And lastly, we are going to talk about snowball sampling. Now, what you should know about the snowball, as the name implies, when a snowball is rolling down a snow, it acquires more snow and becomes bigger. Okay? As it rolls down, it will acquire more snow and becomes bigger. So that is the same concept that is used for the snowball sampling. This is, you don't have access to the population you want to sample. Maybe you have only few access to a population or a unit with a specific characteristics. Now, it is those units that knows their network. It is after sampling the ones that are accessible, then via their own network, they know each other, they are in the same clique. They will now recruit other members into the unit, okay? So what you should know about snowball sampling, initially a small number of individuals with a certain criteria are identified and recruited into a sample, into a study. Then via their own network, they recruit other members with the same attributes. Small number of individuals with a certain attribute are initially recruited into the study, and via their own network, they recruit others into the study. So now we can go back to our question. If you don't forget, we talked about simple random sampling. We talked about stratified sampling. We talked about clustered sampling. We talked about systematic sampling. We talked about purposive sampling, convenient sampling, as well as snowball sampling. So let's go back to the question. Yeah. Now, the difference between purposive sampling and random sampling is A, random sampling only minimize bias. B, purposive sampling is more representative. C, purposive sampling gives less error in estimates. Then D, all of the above, and E, none of the above. Now, you see, purposive sampling is not more representative because all the individuals in the population are not having the same chance of selection. So your answer is A, random sampling minimizes bias. Okay. We shall move to the next question. Okay, there's nobody here. So we said our answer here is, okay, here it says E, A, random sampling only minimize bias. Purposive sampling is more representative. Purposive sampling gives less error in estimates, false. All of the above, none of the above. I think the reason why A is not chosen is because of this only minimize. There are other sampling technique that also eliminates bias. So none of the above will be the correct answer. Now, number 8 says, the main goal of purposive sampling is to focus. The main goal of purposive sampling, okay, is to focus on particular characteristics of a population that are of interest, okay, that are of interest. Not to get a representation of the population. Okay, so we discussed what purposive sampling is all about. You are only looking for the categories that have the same feature. Okay. So your answer here is true. Now, number 9 says null hypothesis implies no significant difference between variables or effects of an intervention. Now, another important aspect of biostatistics is hypothesis testing. You need to understand what hypothesis is all about, and as well as testing for hypothesis. When you say null hypothesis, is hypothesis of no difference. Okay, what it simply means, it means when you are studying variables, okay, you want to study variable A, its relation or effect on B. You have variable A, its relation or effect on B. This is your study. So in formulating hypothesis testing, what is the null hypothesis for this your testing? It will be there is no significant, statistically significant difference between the effects of A and B, or there is no effects in an intervention you are going to carry out in this study. For example, you want to test whether a particular drug, paracetamol, let's make it simple, can be used for treatment of headache. That is your research question or your research title. Paracetamol can be used for treatment of headaches. Your null hypothesis will say paracetamol will have no effects on treatment of headache. That means there will be no effects of the intervention of using paracetamol in treatment of headache. You want to compare A and B, and you said A is similar to B. Your null hypothesis will be there is no statistical significant difference between A and B. So that is the null hypothesis. So null hypothesis implies no significant difference between variable or no effect on an intervention. That is true. So that is what null hypothesis. So anytime you are doing hypothesis testing, you must state your null hypothesis and you must state your alternative hypothesis. If you say paracetamol has no effects on headache, that is your null hypothesis. The alternative hypothesis will be paracetamol has effects on headache. And the aim of that your research is to reject the null hypothesis. You must understand it clearly. Okay? Your aim of the research, you want to reject the null hypothesis to accept your alternative hypothesis. Now, there are some certain guidelines in testing for hypothesis. You used to reject or accept a null hypothesis, which we shall see shortly. Now, there's another concept you need to understand, which is called type 1 error. Type 1 error. Type 1 error. Type 1 error is also known as false positive. Okay? When you say type 1 error, it's also known as false positive. It occurs when null hypothesis is incorrectly rejected. So anytime you see type 1 error, you should know it is what? False positive. So your answer here is true. Now, if we give that example, that simple example, you want to postulate a hypothesis that paracetamol cures headache. And your alternative hypothesis, sorry, you said your null hypothesis is PCM does not cure headache. That is your null hypothesis, which is statistics of no difference or statistics of no effect. You said paracetamol does not cure headache. Your alternative hypothesis will be paracetamol cures headache. At the end of the research, you incorrectly accepted your null hypothesis when in fact paracetamol can cure headache. So you made a false positive error, which is called a type 1 error. So type 1 error is defined as accepting it occurs when you incorrectly reject a null hypothesis. Are we saying it correctly? It occurs when null hypothesis is incorrectly rejected. Now, reject the null hypothesis if p-value is less than the level of significance. Otherwise, do not reject null hypothesis. We talked about level of significance. If you have a normal distribution curve, okay, you have your critical area, you have your alpha level of significance. And for every research, you set a p-value. For that research, you calculate your p-value. Now, these limits are beyond the critical limit, okay? And they are denoted the level of significance. You have a level of significance. After your result, your p-value lies in this region, beyond the critical region, okay? Is less than the level of significance, okay? You have to reject the null hypothesis. So you need to understand this concept. Reject the null hypothesis if p value is less than the level of significance. So you reject the null hypothesis and accept your alternative hypothesis. Otherwise, do not reject the null hypothesis. Now, if the p-value is greater than your alpha level of significance, okay, that is within the critical region, you are going to accept your null hypothesis. At the end of every hypothesis testing, the aim is to either accept your null hypothesis or reject your null hypothesis. And what determines that is where your final result of your statistic, your test statistic, whether it is within this region or within the rejection zone. So if it's within the rejection zone, that is p-value is, and your calculated p-value is less than the level of significance, you reject it. Type 2 error also is known as false negative. It occurs when a null hypothesis is incorrectly accepted. This is true. Type 2 error is also known when you we said type 1. Type 1 is what? False positive. Type 2 error is false negative. It occurs when a null hypothesis is incorrectly accepted. So that is the mix-up we made in the first one. We said type 1 error, it occurs when null hypothesis is incorrectly rejected. Okay? A false hypothesis that is true is rejected. Now you have type 2 error. It occurs when your null hypothesis is incorrectly accepted. Now, what is this false positive we are talking about? What is false positive? False positive refers to a result that is mistakenly identified as positive when it is actually negative. False positive refers to a result that is mistakenly identified as positive when it's actual negative. It's actually a negative result. Okay? And you went and identified it as positive. You marked it, you test. You did a test, and your final result, you say it's positive. When the truth is actually negative. So you failed the correct one. So your positive is what? False. You failed it. False positive. The result is actually negative, and your test is picking it as negative. That is false positive. Now you need to understand the difference between specificity and sensitivity. Now, specificity is a measure of how well a test or a diagnostic tool identify true negative. That is specificity. Specificity identifies true negative. Please don't forget. And the specificity has inverse relation to false positive, because if the test picks a lot of true negative, high amount of true negative, that means the false positive will be very low. Okay. If your test is very specific, that is, it has a high specificity, okay? It means you pick a large number of true negative. So the false positive that will be remaining will be very negligible. So specificity is an assessment of true negative, and it has inverse relation with false positive. So let us see sensitivity. Sensitivity is a measure of how well a test correlates or identifies a true positive. If you remember, we say specificity identifies what? True negative. While sensitivity identifies true positive. That is true. Now, number 16. The mean is the most unreliable indicator of central tendency if data has extreme values. If data have extreme values. Now, what is measure of central tendency? Okay, measure of central tendency is a measure of how close your data or sample or units are to the middle. How close your distribution of data is to the center. That is a measure of central tendency. And you have mean, median, and mode. These are measures of central tendency. Mean, median, and mode is a measure of how values are close to the middle of the distribution. Okay, so when you have a normally distributed data, or when you have a distribution, you might have what is called outliers. Okay, these outliers are nothing but extremes. If you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 60, 70. So that 70 is an outlier. Okay, it's an outlier or extreme value. Now, what you should know, the most ideal measure of central tendency that is not readily affected by an outlier or an extreme value is the median. Is the median, because for you to calculate the median, one, you must arrange your data or variable in orderly, either an ascending or a descending order. Then you now take the middle value. Okay, you now take the value at the middle. If it is more than 1, you take the average of the two middle numbers. So the median is least affected by an outlier or an extreme value, while the median is the mean is most affected by an outlier. So the mean is the most unreliable indicator of central tendency that has an extreme, okay, that has an extreme values. And we said the median is the most reliable when your data is skewed or when your data has an extreme value or an outlier. Mode in the measure of central tendency is just the number that appears most frequent. If you have a distribution, let's say, of numbers, the number that appears more frequently in that distribution is the mode. So these three are measure of central tendency, which is a measure of how close values are to the center. So number 17 says standard deviation is a measure of dispersion. Standard deviation is a measure of dispersion. True or false? That is true. We said measure of central tendency is how close a value is to the middle. One measure of dispersion is how dispersed or disorderly a variables are. Okay, so we shall see the various types of measure of dispersion. Measure of dispersion is how is a measure of how spread out or how scattered the values in the data sets are. Okay, and the various measure of dispersion include one, range. Range is the difference between the highest minus the lowest. That is range. It's a measure of dispersion. Now, you have to take note of this because of your MCQs. Which of the following are examples of measure of dispersion? Which of the following are measures of central tendencies? 2, variance. 3, standard deviation. 4, mean absolute deviation. 5, interquartile range, which is the difference between the third and the first quartile or percentile. The first quartile is 25th, the third quartile is 75th. So that is the interquartile range. Okay, now just this, we can't go into the details of all this, but you should know that all these are measure of dispersion. Now, histogram. The histogram is used for representing ordinal data. Now, what you should know about the histogram is used for quantitative variables that are continuous. Okay? Quantitative variables that are continuous. While ordinal data are usually categorized. Now, if you have maybe temperature 1 to 100 degrees centigrade, it's a continuous thing. You can plot a histogram for that, okay? You have age. You can plot a histogram. Now, when you are talking about an orderly that usually can be categorized, it's ordinal data, you best use bar charts. In ordinal, they are not continuous. The most important feature of a histogram is the variables are continuous. So you don't have space in between the bars. While in bar charts, you have space in between the bars, in between the bars, and there are various types of bar charts. Okay. So you should know that this is false. Okay. Then number 19, according to empirical rule, approximately what percentage of normal distributed data lies within one standard deviation? Now, there is what is called the normal distribution curve. Okay. In a normal distribution curve, the empirical rule states that every single standard deviation, okay, you have the first standard deviation falls within 68% in the empirical rule. The second standard deviation falls at 95%. And the third standard deviation falls at 99.7%. So you have standard deviation first, second, and third. So the first standard deviation falls at 68%. The second standard deviation in a normal distributed curve falls at 95%. And the third standard deviation falls at 99.7%. So if you look at this question, according to the empirical rule, approximately what percentage of normal distributed data lie within one standard deviation of the mean? So the mean here you have 68%. So this is the last question for biostatistics before we go into a practical community, general community medicine questions. Now, number 20 says, rank the following measure in order, okay, in order of least affected by outliers to most affected by outliers. We already mentioned what outliers are. Outliers are extreme values among distribution. Now we are asked to arrange in order from least affected by outliers to most affected by outliers. A says mean, median, mode. That is wrong because you can see mean here, median is least affected by outliers. So B says median, mean, range. Of course, you see here median is more affected by mean. In fact, median is the most affected in measure of central tendency. Now, because this is a measure of dispersion range, it is more affected by outlier than mean. So your answer here is B. The least affected by outlier is median, and the most affected by outlier is range. So this is the last question for biostatistics. So I'm going to unmute you guys. If you have questions, then you ask questions. Then we'll now take a 10 minutes break. I don't know, maybe we'll continue with O&G so that we have some, I hope it's not boring. Then we now continue with public health again, okay? Because throughout today we are going to be busy, and throughout is going to be online. So if you have any question on what we've discussed so far on public health, biostatistics, you should ask. Even though I'm not a public health physician, I'm a surgeon, so you can expect some high margin of error. So any question, you should unmute yourself and ask, please. I'll mark you it is recorded. Later, the slides will be shared and the recording will also be shared so that you can use everything for revision. Don't type me a question. Unmute yourself and ask. Somebody is asking, West, please can you send us the copy of it? That is what I just said. And of course, today is bonus. Tomorrow, only registered candidates will gain access, and also even in the physical classes. Okay, the first question is whether I'm sending a copy. Yes, of course, I'm sending the copy and as well as their answers, because in workshop, it's just to spoon feed. You are not supposed to think anything is to write. Just read and go and answer. That is what workshop is all about. So any question? Any question? Any question? If you have any question, you unmute yourself. If you don't ask question, I will assume everything is clear. Okay, let me assume everything is okay. So we are going to take a 10 minutes break. Let me see if I have. Okay. We are going to take a 10 minutes break. Oh, somebody says they can't unmute themselves. Okay. Let me see. Allow participants. So you have questions. So now you can unmute yourself. Yes.
Okay, so please can you go over sensitivity and specificity again?
Okay. The first question, let me take note of all the questions. One, sensitivity. Specificity. Yes, any other question? Any other question?
Okay. Sir, please, can you repeat the last part of this median, being the most affected by an outlier and mode the least range? I don't understand.
Okay, outlier. I did not say median, I say mean. Okay, median is the least affected. Our range is the most affected. Okay. Median and range. Okay. Any other before I start answering? Okay, I believe there is no other. Now, let's go to the first question. We said sensitivity is a measure of false positive. Is that what I said? And specificity. Sorry. Here is true positive. Sorry. Let me
true positive.
So you are following. Positive. Specificity is a measure of what? True negative.
True negative.
Now, what does it mean? You have a tool, an investigative tool. You want to measure some certain parameter, okay? That investigative tool among the sample, okay? Sensitivity, you want to test how sensitive a test or a tool is. Testing how sensitive a tool or a test is the ability of that test to pick all the true positive. In your population, you are testing for hepatitis or HIV/AIDS, HIV. A highly sensitive test will pick all those patients that are positive. Okay, it tests true positive. Do you understand? Sensitivity is a measure of true positive of an investigative tool. It picks all the individuals that have a disease that is being assessed for. Why specificity? Picks all that are true negative. Now, what you need to know about tests, there are some factors that will make a test to pick an individual that is negative as positive. That is called false positive. A test wrongly picked an individual that is negative. It read that positive as positive. That is false positive. So what specificity does, it will now say, okay, of all these patients that are positive, you want to eliminate false positive. It is specificity that will get the true negative amongst them. You understand? So the ability of a test to pick individuals that are truly negative among the population is the specificity of that tool. Now, if you go back to the slide, let me share the slide again. That is question what? Yes. We said specificity is a measure of how well a test or diagnostic tool identifies true negative. And we said it has inverse relation with false positive. Now, the higher the true negative, you have a very little false positive because you are eliminating all the false positive. Okay, it is the specificity test that will now say, okay, of all these false positive, there may be some that are negative. When you subject them to specificity, it is more specific. Now, maybe if you have a screening test will have a very high sensitivity. But when you are talking about a diagnostic test, it will have high specificity. Do you understand? Maybe an individual is exposed to an antigen. If you evaluate his blood, he might be positive for that disease. But if you are going to do a specific test that is diagnostic, maybe Western blotting, when you are talking about HIV, you just did a rapid screening test and it shows patient is positive. And you now need a Western blotting and it shows that patient is negative. So that Western blotting is more specific. Okay, it's diagnostic. I don't know if it is clear. Is that clear? Who asked the question?
Yes, sir.
He has run away. Okay. So I think you've eaten 5 minutes of the 10 minutes. So we are going to take a 7 minutes break. Exactly by 11, we are going to continue. Meanwhile, I'm going to share the slides on the page. Okay, so we'll start immediately by 11. We'll continue. So thank you very much. We are going to still use the same link, please. The same link.